No, okay. As per the group, okay, only one or two students said okay they could able to get it. Okay, how about others? Hello, Harini. Harini, can you unmute?
Yes, sir.
What happened? No, we should get to know. Okay, what is you people are understanding or not? I should know. No, nobody is speaking. Then how do we understand? Okay, what is your understanding level? How do we think? Okay, how many of you got it? How many of you didn't get it? Is an issue here in finding out this?
No, sir. When you send the answers, then I got it.
So what to do now? Okay, in the examination, first I'll send the question paper, send the answer, then I'll ask you people to solve it. It will be easy then. Correct? Always okay. You people find it difficult whenever you see the question. So maybe it is because okay AMCD or KCN sir is sending the questions. Okay, it will always tough. What is why that? Hmm? No, basically it is. We're not doing anything different. What is being told, no? Why it is not being understood at that point of time? Okay, when we are teaching, I don't know. Okay, okay. What is the what's the problem here? Suppose in this okay, what is that? Current mirror. What are the issues that you people have? Anybody? What is that you're not getting? So where I should repeat something? What I should repeat? Hmm? Hello, hello. Nobody speaks. So then we'll stop the class. There is no point in teaching you people. Okay, when no one is responding anything. So I'll end the meeting. Shall I? Share of the class. What is the mood of the class? Share, are you there? Hello, hello, hello. Can somebody represent the class? May not be here. No representation.
Hello, sir.
Hmm. Who is this?
Sir, Vilas, sir.
Tell me.
Sir, sir, I got answer for one, and but I second one I forgot to. It means I didn't get to putting KCL. But my doubt is,
Hmm.
they are giving W by P and W by W by LP and W by N, W by LN. Sir, what would be the difference, sir? It will not make any difference. Such difference, no,
It will
sir.
make a lot of difference, man. This is W by L because their KPs will be different, no?
Yes, sir.
Kp of this will be 200 microampere per volt square and this will be of 100 microampere per volt square, which will be of course
Yes,
for
sir.
PMOS it is mu p. The mobility of holes is different compared to mobility of electrons. So in that way, if you want to have, I don't know how to explain you people. So you are asking me a fundamental doubt. So assume that ID of an NMOS transistor is given by, so half in case of saturation region, half Kp W by L. Okay, let me write it as N VGS minus VTO whole square. Correct? In saturation region.
Yes, sir.
Assume that
Yes,
this
sir.
is 1 milliampere. This is 1 milliampere. Correct?
Yes, sir.
And if the WL of this is some X value, and if you keep same VGS and VTO, but Kp can never be same. So what is Kp is equal to actually? It is mu n into Cox. For Kp of n, because we simply say Kp doesn't mean that this is for PMOS. Kp is kappa. So this is mu n into Cox for NMOS. Kp for PMOS, you can again write one more suffix Kp of P, which is mu P into Cox. Mu P into Cox. This mu p is mobility of holes and this is mobility of electrons. So mobility of electrons is almost 2.5 times of mobility of holes. So this is always the case. This is always the case. So in such case, when the mobility of holes is equal to, sorry, when mobility of electrons is more than mobility of holes, in order to get same current in what PMOS also. Suppose if I write the magnitude, it is half into, let me write it for this. This is Kp of P, W by L of P, and then VGS minus VTO whole square. Correct? Is
Yes, sir.
this Kp of P always less than Kp of N?
Yes, sir.
So, if you want to get same current with the same VGS minus VT whole square over here and here, are you supposed to have W by L of P different compared to W by L of N to have a same current?
Yes, sir.
So, naturally, the W by L of PMOS transistor will be different from that of a NMOS transistor. So they can't be
Okay, sir.
they can't be same. Of course, they can be same also. If it is same, the required value of VGS will differ because same current has to flow because they are in series. Then the required amount of VGS will certainly change. Of course, that requires
Okay,
to
sir.
understand all these things. It will not happen just by seeing my answer and listening to my answer. You have to do the simulations, then only you can understand. Otherwise, just doing one or two problems will never help you to understand this AMCD. So that's why we have integrated the lab simulation to this one. So you have to do simulations, then only you can able to understand. Okay. We used to write a current source here, no? Correct? Okay, and somebody unmute. Harini, can you unmute? Hello.
Yes, sir.
This is the
Yes, sir.
typical circuit we used to write. So this is, you can see there is a current source coming down here. So practically you cannot have a current source. There is nothing like current source in any actual circuit. Maybe in simulation you may write a current source, but in actual practice you don't have a current source so that you can put it over here. So the actual circuit will be something like this. So you're going to have a resistor which in turn makes some current to flow, make some current I reference to flow. So this is what is I reference, which is the representation something like this. Correct? Now,
Yes, sir.
if the W by L of this is equal to something like take it as 50, and if you want to have a I reference of maybe 1 milliampere, if you want to have an overdrive voltage of around 0.2 volt with VTH as equal to 0.4 volt, correct? And let me take this
Yes.
WBL of this as around 75. I want to know what is this R reference and R D2. Let me write it as this is M1, this is M2. So let us take Kp for both of them as 200 microampere per volt square. My question is, what is the R reference max you can put? What is R reference max and what is R? I will write it as I2 here. So what is I2? If RD2 is equal to 100 ohm, and okay, I want all of you to solve this. I reference required is 1 milliampere, VOV is 0.2, VTH is 0.4, Kp is 200 microampere per volt square. I want you people to find what is reference max you can put so that 1 milliampere current can flow. Just a minute. Okay, now first find what is, let me take out this. First find out what is the current that may flow. Can you find the current? Because WBL is given. So for finding current, what all things you require? You know Kp, you know WBL, you know VGS max VTH, you can find what is I reference. And then you find what is the maximum resistance that is required, that is possible to have that much I reference to flow. So forget about this I reference. Give me what is I reference.
microamperes.
How much?
200 microamperes.
So I
We
reference
overdrive it.
V overdrive is how much?
0.2 is
0.2. Is that correct? I have taken
Yes, sir.
0.2. Is it 200 microampere?
Yes, sir.
All of you got same value? Okay, perfect. Then to have this 200 microampere to flow in this circuit, what is the maximum possible value of RF you can have? So I want to, okay, all of you, did all of you got it as 200 microampere? Just put in chat box and find what is our reference max.
Yes, sir. 9 kilo ohms.
Hmm?
9 kilo ohms or
9 kilo ohms.
seconds.
How? Give me the calculation for this 9 kilo. I'll give you 5 minutes. Yeah, how much is R max? R reference max. How do you find R reference max? Hello. Look, can somebody say how to find R reference max? Suppose assume that, okay, I taught all these things. If I ask some questions, you say that, okay, this thing is not at all done in the class. See, how much the current that is supposed to flow?
Amperes.
Huh? 200 microampere.
One. Yes, sir.
200 microampere is a current is supposed to, of course, this is, forget about this I striked it off. So if 200 microampere current has to flow, is this MOSFET should be in saturation region?
Yes, sir.
How much is the voltage required to keep it in saturation?
0.4, above 0.4.
Here, see here. See, this is above 0.4. Because of this connection, what should be the voltage that should be here?
1.4, sir.
Hey, come on. This is 1.8 volt. How
Yes,
much
sir.
is VOV? 0.2.
0.2, yes, sir.
How much is VTH? 0.4.
0.4.
How much is VGS then?
0.6, sir.
Is it not 0.6 volt here that should be maintained here? Is the same thing comes over here?
Yes, sir.
Is it 0.6 volt minimum required to keep it in saturation because of this diode connected connection?
Yes, sir.
How much is the voltage that is there across this now? Is it not 1.2 volt difference between this? This is 1.8, this is 0.6.
Okay, yes, sir.
Shall I say I reference into R reference is equal to VDD minus VD?
Yes, sir.
Is it not equal to 1.2 volt? Can I write
Yes,
now
sir.
R reference is equal to 1.2 by 200 micro?
Yes, sir, we can.
Correct. Then how much is this 1.2 by 200 micro?
Um, 6 kilo ohms, sir.
6. So this is the resistance. Correct.
We should take voltage drop across resistors.
Then
Yes, sir.
because if you want to have a current of this is maximum, even you can keep lesser than that. If you keep less, what happens? This voltage will be, of course, you need to keep a resistance of 6 kilo ohm. Then you're going to have a current of so and so.
Yes,
Correct.
sir.
Of course, what I want you people is you just vary this, see whether the current changes or not. Those are the exercises you have to keep doing it. Suppose, let me not say it as RD max. Suppose if you keep it as, okay, shall we do a simulation? Let me just do that simulation. I don't know how many of you will appreciate this or not. Let me just go to, okay, if I can have that. Okay, let me just take a new circuit. Okay, what is that is required? What I want now is, this is not visible, no? Okay, let me share it. This is NMOS 4, this is one here, the other one control R, control E, control R again. Is this fine? And we need to have a resistor. Where is the resistor? Put a resistor here now. So let me put one more resistor on this side. Let me just make this short. Okay, I'll take one more. Voltage source. Where is this? I'll take source. This is F3. Connect it from here to. Okay. Make this 1.8. Okay, I'll make this 100 ohm. Just for the time being. So this I want to have it as 6K as per my requirement. I'll make this WL as 10 micro, and then we want to have 50, no? Let me make it as 500 U, and then this one let me make
75.
it 10 U and then 750. So that ratio becomes 75. Correct. So we are done with this, and then KP, sorry,
Ground connections.
ground connection I'll do, and then model file dot model NMOS open the parenthesis KP is equal to 200 micro,
micro.
VTO is equal to
0.4
0.4. That's all.
lambda.
Lambda is not required for the time being. That is fine. Okay, now you are done with this. I will put a ground. No, at least those who have laptops, you should be keep doing it, I say. No, unless you do it using laptop simulation, nobody will help you out. So I will do .op, or let me do one. Okay, edit simulation command, simply do .op and then do it. Let me run. See now how much the current? Is it 200 microampere? Hello.
Yes, sir. It's
Is it okay? Is it 200 microampere?
yes, sir.
It is, no? How
Yes,
about
sir.
the current in M1?
300, sir.
300. Why it is 300?
We can current. It is current meter.
Because it is 75 divided by 50 into 200. 75 by 250 is 1.5. 1.5 into 200 is 300 microampere.
Yes, sir.
Correct? You can see you can still able to mirror the current 1.5 times because the ratio of M1 by M2, the WL of M1 by M2 is 1.5. Correct?
Yes, sir.
You can see we are not using any current source. We are using a resistor. Perfect? Now,
Yes, sir.
of course, if I make this equal to 4K, what might can happen? Shall we do it?
The current will change.
We'll just check it out. Okay, what happens if I make it 4K? Now, if I make it equal to 4K, and then run it here, can you see M2 has changed?
Yes, sir.
It has become 289 microampere.
289.
Maybe what is the reason?
The change in the velocity, right, sir.
Change in?
VGS value.
Does the VGS change?
No, sir. It remains constant.
No. Does the VGS change compared to 6K and 4K?
No, sir.
No or yes?
Yes, sir.
How it is yes? See here, for this particular circuit, if I just share my camera, can I write ID reference is equal to half Kp W by L of reference transistor multiplied by VGS minus VTO whole square. Am I correct? This is the expression. But what is VGS? VGS is what? I'll just again show you this. Can I write VGS is equal to, because VGS is the voltage from here to here, is it not equal to VDD minus ID into R1?
Yes, sir.
So can I write this as, I'll just show it again. Is it not VDD minus ID into RD reference? So now is
It does
ID reference is equal to 1.2 Kp W by L of reference into VDD minus
minus-
ID RD, okay, whatever reference we have, minus of VTO whole square. Now you substitute this as 50, substitute this as this is unknown, this is again unknown, this make it as ID, let us make it as 4K. Just find out what is the current. This is 0.4, it should be 289. I think all of you can, this is 50, this is 200, VDD is 1.8, ID you are supposed to find it on either side. Give me what is the value of ID there. It has to be as per simulation, it should be how much? 289 microampere. Martira, I will also do simultaneously along with you people. Let me see, do we get same answer? Shall I write, okay, alpha equals 100 exponential minus 6 into 50 into 1.8 minus alpha A into 4 exponential 3 minus 0.4 whole square, shift cal. You can see one current is 4.22 into 10 power minus 4 ampere. This is one possible current. One more what I'm expecting is, okay, let me just say equals 0.1 exponential minus 6 equals cal or shift cal. Can you see it is 2.89 into 10 power minus 4. Is it not 289 microampere? How many of you got this? Hello.
Good, sir. Yes, sir.
No, this is what I want all of you to get it. It's not only one or two or only myself getting it. How many of you got this answer? See now, in the simulation, if you change the value of RD, this R1, the current will certainly change. if you want to have a current of 200 microampere, you have to have 6 kilo ohm. So now tell me, if you want to have it as 1 milliampere, can you find out what is the value of RD required? To have a current of 1 milliampere, what is the value of RD required? Next question is, what is the value of RD for a current of 1 milliampere as my reference current? Put in the chat box, okay, how many of you got the previous answer of 289 microampere? Put in the chat box. If you're not getting it, okay, nobody can help you out. Is there any doubt on this particular equation to anybody? How did I write this expression? How did I write this expression of Kp? Sorry, Id is equal to half Kp. Okay, I could able to see many of you getting the answer. And tell me what is the value of Rd for a current of 1 milliampere?
952, sir.
952. Okay, let me just do it immediately now. Let me make it 952. Let me just close this. 952, 952. Let me run it. It should give me a current of 1 milliampere close to. Am I there? I'm almost there. It is very close to 1 milliampere. Then what is the current that is on this side? On this side? It should be
115.
1.5. 1.5.
1.5.
1.5. Can you see it? This is 1.5?
Yes, sir.
1.5. So easy. Correct?
Yes, sir.
Did all of you get it? Okay. Who said this? Who said 952? Someone said, I could not make out. 952. Ashwini, did you say this? Okay, somebody said it. Now,
Yes, sir.
tell me, what is the maximum value of R2 that is possible to have a current of 1.5 on this side? If you want to have a current of 1.5 milliampere, that is 1.5 times the I reference, what is the maximum possible value of R2 you can have? Getting my third question? Third question is, what is R2 to have a current of 1.5 times than that? Correct? How to find that R2 max? How much? Hello? Are you all there? Gayab. ಏನು ಮಾಡ್ತಿದ್ದೀರಪ್ಪ ಎಲ್ಲ? Is this equation correct? R2 max is nothing but Vd minus Vds at M1, that is on the right hand side, which is of course in this MOSFET it is M1, correct? So it is VDD minus the minimum voltage required to keep this in saturation. What is the minimum voltage required to keep this M1 in saturation? Hello? Come on. Hello? How much is VGS here? Okay, sorry. Before that, let me just first find out what is VGS. How much is VGS here?
It's 0.84.
Is it 0.84? Then this slightly
Yes, sir.
changes. This slightly changes. This is 0.447. This is 0.447. Then this will be 1.8 minus 0.447 divided by 1.5. It is 1.8 minus 0.447 divided by 1.5. Is this correct? Any comment on this? Hello. Did all of you get okay? Why I wrote it as 1.8 minus 0.447 divided by 1.5? And why this is 9 naught? Of course, this ratio is 9 naught. Why this?
It's VDS value. That's
This is VDS SAT, not VDS. VDS SAT.
so VDS, from the KVL equation you can get.
Is this fine? Okay. Why here we have taken it as 0.447, whereas finding out your the value of this value, where is that? Where is this? How did we find this 952? For 952, okay, how did we get it as 952 there?
VGS by ID value, right?
See the difference here. In the first case or in the mirrored current, we are taking it as VDS SAT, whereas for finding R1, can you see this is we have taken VGS? This is a major difference. Why here it is VDS SAT? Why it is VGS here? Looking at the circuit, what is the minimum voltage required to keep this MOSFET in saturation?
It's VDS SAT values.
VDS SAT, which is VGS minus VTH. Since VGS is 0.847, VTH is 0.4, the required voltage to keep it in saturation is hardly 447. That's why I have substituted 447 here, millivolt.
Sir.
Correct? Whereas for the other circuit over here, what is the voltage that is required for 1 milliampere to flow with this connected? It's again 0.487. It's the same 0.487 is required. Since the gate and drain are shorted, even VDS should also be equal to 0.487 to keep a current of 1 milliampere. Correct?
Yes,
in
sir.
such case, what is the minimum voltage that you should maintain here? It is VGS only. It is
VGS
not
value.
VOV. It is not VDS SAT. VDS SAT itself is VGS because you have shorted these two. So that's why over here for the resistor or on the reference side, it is VDD minus VGS M2. Correct? Hello.
Yes,
That's why you
sir.
can see it is 953 and this is 902 ohms. correct? This is the maximum possible. You can see now, suppose if I put it, suppose if I put a resistance of, let me just do it. If I put even 500 ohm, will I get the same current? Will I get the same current of 1.5?
Yeah. Yes, sir.
See here, where is that? Where is that? Is it M1? Where
ID
is?
M1.
Okay,
Down.
wait. Where is that? M1. Can you see here? This is 1.5.
Yes, sir.
1.5 milliampere. Suppose if I make it 2K,
It will change. We get to linear state.
if I make it 2K, if you try to find the current here, it will not mirror properly. Can you see here? It is
Yes, sir.
826 microampere because this is in now linear region. That's why the maximum resistance that you can put here is 902 ohms. So let me just make it 902, make it 902, and then find out the current. It will be very close to. Can you see it is still here?
Yes, sir.
Can you see what is the voltage at this point? This is, I think, N003 is nothing but this node. So let me just name that node as something like output so that you can make out. I will make this as output and then connect this to this. Okay, run it again now. Can you see this is output 0.446?
Yes, sir.
So is this 0.446 is the value that we have substituted here? Just a minute.
Yes, sir. Same value.
Okay. Oh,
Subtract on
can you see it is same 0.447446?
Yes, sir.
Suppose if I make this equal to more than 902. Now if you make it even just 950. 950 if you make it, just have a look at this output voltage and the current. Does the output voltage reduced?
Yes, sir.
Gone below
Significant.
447 micro?
Yes, sir.
What does it mean? What does it mean? It means that this M1 has entered linear region. That's why current has reduced from 1.5 to 1.47 microampere. Sorry, milliampere. Correct?
Yes, sir.
Okay, what I'll do next, I will just make this 902. I will introduce a term called lambda. Correct?
Yes, sir.
LAMBDA is equal to 0.1. Okay. Can you re-estimate what is I reference? I want people to re-estimate the value of. Okay. Okay, let me otherwise run it now. Does the current will be less or more? Let us just find out. Now you're getting a current of 1.01 milliampere. Instead of 1000 microampere, it is 1015 microampere. How did you get 1015? ID is equal to half Kp W by L multiplied by VGS minus VTO whole square multiplied by 1 plus lambda VDS. But what is VDS? VDS is equal to VDD minus ID into R reference. Okay, do I need to do this? Correct? How much is ID? This one you have, sorry, is this 952. I'll again go here. This R reference is 952. So shall I write ID is equal to half into 200 micro into 50 into 1.8 minus ID into 952 minus 0.4 whole square multiplied by 1 plus 0.1 into 1.8 minus ID into 952 minus 0.4. That's all. This is VDS. Sorry. This is not there. This much. This is VDS, no? Find for ID. Is it 1015 microampere? It is okay. Alpha equals 100 exponential minus 6 into 50 into 1.8 minus alpha A into 952 minus 0.4 whole square multiplied by 1 plus alpha A into 952. Shift can. Sir, class ನಡೀತಾ ಇದೆ ನಾವು 12 to 1 ಮೀಟಿಂಗ್ ಇತ್ತು ಒಂದು. Okay, you are supposed to get a current of 1.12 milliampere, which is almost there. So are you not getting? Okay, let me just find out another route. So another route, let me just equals
1.11, sir.
yeah,
1.8.
that's okay. So let me make it as 0.1 exponential minus 6 plus. Okay, there are two values. One is 1.85 milliampere, other one is 1.12 milliampere. So are we getting very close to it? Let me run this now. Can you see, do we have current almost close to 1.12? This is not exactly 1.12. This was supposed to be 1100. It is now 1015. There's a 100 microampere of difference. So that's not a big difference. Maybe around 5-10% of error is there. That's fine. Hello. What is if this is 1. Okay, let me just make this as maybe 100. Would you like to have twice of that current? Hello. How much the current that you are expecting on this side, because this WL is made twice of this?
2 times.
2 times of that. This is, if it is 1015 microampere, here it will be 2030 microampere. What I'll do is I will slightly reduce the value of this to around maybe 100. Let me see how much I'll get it. Can you see it's almost there, double?
Yes, sir. 2.
Can you see it's almost double?
Yes, sir.
1015 microampere. Here it is 2200. You're almost there. It
Yes,
is
sir.
slightly more. It is slightly more here. Why means? Because this VDS is also more here. Correct?
Yes, sir.
Now,
Value.
what I want to say is, with lambda, I mirror, is it not equal to W by L of reference into 1 plus lambda VDS of reference transistor divided by W by L of mirror into 1 plus lambda of VDS of mirror transistor. So am I correct here? Just see with this. Just see this here. Now you can see it is not simply, okay, let me write I reference. Am I correct?
Yes, sir.
It is what? The I mirror. Oh, sorry, one second. This should become reverse. This should become mirror. This should become reference. This should again become mirror. This should become reference. Correct? Right. I of the mirror is equal to W by L of mirror multiplied by 1 plus lambda VDS of the mirror divided by W by L of a reference transistor. I'm just writing in general, plus lambda VDS of reference, whole thing multiplied by I reference. Correct? In the previous case, when lambda was equal to 0, does both these terms go off?
It's one by one.
That's what. If lambda is equal to 0, what is I mirror is equal to? Is it not I reference multiplied by W by L of the mirror divided by W by L of the reference?
Yes, sir.
Why you're not cancelling out these two when lambda is non-zero? Can I cancel these two out?
No, sir. The VDS values will be changed.
VDS will be different because what is the VDS that is required for the mirror transistor? The VDS required is VOV is enough required. Correct?
Yes, sir.
If okay, for this, do you require VOV plus VTH as the VDS?
Yes, sir.
Since even though your assume that W by L of mirror is equal to W by L of reference. If lambda is equal to 0, do you get I mirror equal to I reference? If these two are same?
Yes, sir. Yes, sir.
But when lambda is non-zero, these two currents are not same. These two currents are not same, even though these two are same. Why?
Because of the this is V0 values and
This
values.
the VDS matters. VDS matters. So it is always necessary that VDS of both of them have to be same. Then only you will get the mirror current as equal to I reference multiplied by these two ratios. Suppose if this VDS of mirror is also equal to what is that, VOV plus VTH, then you will get the same current. Same current,
Yes,
matlab the ratio of this multiplied by I reference. But since you want to keep, if you want to keep the second transistor saturation, the required voltage is less compared to the voltage that is required to keep this in saturation. Am I correct?
Yes, sir.
How much is the voltage that is required to keep this in saturation? If you can see here. ಎಷ್ಟು ಬೇಕು?
The 0.8. It's not visible. Can you?
It is visible. Okay, let me just see.
No, sir.
Is it 0.833?
Yes, sir.
We'll just do that. So what is VDS of reference transistor? It is 0.833. Am I correct?
Yes, sir.
If I get exactly the same voltage on the other side, so is it now, okay, how much is the ratio we have? We have the ratio as 2 milliamp, okay, 2. It is now 1.015 into 2, which will be 2.03. It is 2.03. Okay, now what I want is R2 is equal to 1.8 minus 0.83333 divided by 2.03. So it is now 1.8 minus 0.8. So if the resistance is 0.476, that is 476 ohms, I'll exactly get. One second, how much is this? Oh, this I made it 10, this should be 1000. How much, sorry, how much is this? This is 500, this should be 1000 because I want to make it twice. Okay, let me make this and run. This is interesting. Just have a look at these two OP and outputs. Sorry, just see what is this. N002 is this voltage.
Yes, sir.
How much is that?
0.833.
How much is the voltage at this point?
Same, 0.833.
Can you see, because the voltage, the VDS of this and this are same, even though you have some different lambda, can you see the current of this M1 is exactly the ratio of this divided by this multiplied by the raise. Okay, the current here. How much is the current here?
Yes, sir.
1015 microampere. How much is the current that is coming over here? It is exactly twice of that. That is
Double.
2031 microampere.
Yes, sir.
Now, suppose if I actually reduce the resistance to 100 ohm, what will happen?
It will change, sir.
Why? Okay, does this current increase?
Yes, sir.
Why?
Because VDS value will be different.
VDS will be less or more? Will it be less or more?
It will be more, sir.
Let us see. When it is more, current will also be more. See here, is it not 1.58?
Yes, sir.
Is the current more than double of this?
Yes, sir. 101. Yeah, yes, sir.
It would have been 2030, but it is 2172.
Yes, sir.
Correct? Fine.
Yes, sir.
What is the maximum value that you can keep here?
912.
How do we find out that? Okay, we can find out that value. No need to just, okay, how much is this VGS? Let us just find out how much is VGS. VGS is 0.833 minus 0.4, and current that is flowing is 2030. Then 2030 was multiplied by 1.8 minus 0.44433.
213. So 213.
Let me just make it equal to 673. I have to increase the resistance such that, can you see this now? V output. V output, is it close to VOV required?
Yes, sir.
This should become how much? This minus 0.4. This is still not sufficient, because if I change this value, my VDS also changes.
Yes, sir.
Can you see this? Whatever output voltage you have should be less by the VTH value, then only that lambda effect will going to come into picture. Now, why we are doing this exercise is the improvisation of this mirror circuit will be a modified mirror circuit, which we call it as a cascode mirror. So in that case, we will use a modified circuit which is other than this. So why we want to use that modified circuit is because the current mirroring from I reference to this I mirror will not only depend on the ratio of this M1 and M2, it also depends on the VDS of this transistor and this transistor. Suppose if VDS of this transistor is different from this, then the current mirror not only depends on the W bell, it also depends on VDS. If you want to make the current that is flowing in this mirror transistor to be just the ratio of W bell of this and this, then you have to make this voltage should be same as this voltage. Then only we will get the current that is flowing in the mirror circuit exactly the ratio of the W bell of mirror circuit divided by the W bell of the reference circuit. Okay, let us see one or two more simulations in the coming classes, and then okay, maybe let me just give you some assignments so that you can able to do something in simulation then submit. Okay, then thank you.